causes any impacts below a certain velocity to be treated as inelastic, and this is normally done as a performance optimization when you're dealing with objects that are
You're
going to
quiet,
be
Daniel.
when you're dealing with objects that are going to be you know, complicated scenes, lots of objects, things that are going to be changing velocities regularly under user control or whatnot. We're dealing with only a handful of physical objects, and so we need a really detailed simulation. To that end, it's a lot easier to just it's fine to drop the threshold to the minimum. So basically, this ball, we're indicating that it's never really going to stop moving. So we've reduced the velocity threshold to the lowest possible setting. And I bumped the number of iterations up from 8 to 100 and 3 to 100. Because I'm, again, for this this type of game, it's not going to be that taxing on the CPU. We can crank up the resolution of the physics engine. A couple of other changes that I made just to make things a little bit more interesting. I changed the collider on the brick from a box collider to a capsule collider. And you can see here, that's giving it a bit of a rounded edge. This is going to help so that when the ball comes in at weird angles or near corners, it's actually going to deflect a little bit more dynamically. And this is more of a personal preference. And I've done the same thing with the paddle. For the paddle, it's especially useful because in this case, you can see I've added kind of a little bit of give on the edge of the paddle. So the physical paddle is actually a little bit bigger than the visual one. This makes it a little bit easier for the player, and it also allows you to try and develop a technique of getting corner shots. So if you are trying to get the ball to move in a different direction, because otherwise if it hits the flat surface, it's going to just kind of bounce off in a perfect reflection. And you can't really control the direction of the ball very easily if you hit anywhere on the flat side of the surface. But by giving it these rounded corners, a strategic player can alter the trajectory of the ball. So you can see here that it's sometimes the ball will hit the corner, and instead of just bouncing off in a straight line, it'll veer wildly. And if I can get the ball to hit right on the right corner there, you can see that there's a sharp change in the direction that the ball's taking, and that way I can try and shape the trajectory of the ball a little bit more. And I'm not just at the mercy of a pretty simple physics simulation. All right, so we've also got this lives counter, and it's very basic debugging information. You can see that every time the ball's below the paddle, the lives are counting down. What we need to do at this point is actually have it where hitting that trigger zone is going to cause you to lose a life and reset the game back to its starting state for you to be able to launch another ball. And then if you run out of all of your lives, to bring up the game over screen and allow you to start over so that we can close out that game loop. So that's where we're going to begin today and focus on closing out that the game loop, at which point we've basically got breakout, which isn't exactly ARKANOID, but ARKANOID is breakout plus power-ups. And depending on how quickly we get to that, we may either get to the power-ups within this episode or at the beginning of the next episode. All right, so first order of business, we've got this ball and we can fire it, but it just always starts from that location. We don't have any control. And traditionally, in ARKANOID, the ball starts on the paddle so that we can figure out from where we want to fire. So we will do that. I'm gonna physically drag the ball over. I could do something really fancy where I try to like use a collider projection to figure out exactly where the ball should go. But in this case, it's going to be a little bit easier to just line it up visually. And I want the ball to stick to the paddle initially so that I can uh, move it around before I fire. So again, the easy way to do that is going to be able to take the ball and make it a child of the paddle. Since I'm controlling the position of the paddle, anything that's a child of that object is going to be translated proportionally whenever it moves. So at this point, we've now got a ball sticking to the paddle, and I can fire it, but because it's still stuck to the paddle at this point, it's not working the way we would expect it to. We need it to be back in the main scene once we fire. So the point at which we fire the ball and we give it its initial velocity, we also need to detach it from the parent. And so this is done by changing the parent transform property of transforms. Transforms can form a linked structure. In this case, a tree. We've got them visually here. Any object can have at most one parent, but an object can have multiple children. So it's just like a file hierarchy. You know, you can have any folder can only have one parent folder, but a folder can contain as many subfolders as it might want. So with that quick edit, no, it's not, because I need to save. All right, go back. Has compiled, we run. Now the ball's independent once it's been released. And now we need to change the behavior so that when it hits that ending scene or hits the point where it loses a life, that it resets the game for the next firing. And in order to do that, what we need to do is reattach the ball to the paddle and relative to its initial position that we saved. So the way we're going to do that is by storing it when the application starts. And there are two functions that we can use in order to do kind of a one-time operation on something. One is called awake, and this is called whenever an object is constructed. So if you instantiate something, when it first comes into existence, it gets awakened, and that will allow it to build any other objects that it needs to do, grab references to things. In this case, I don't want to risk the chance that the ball's position hasn't been dealt with, that it itself hasn't awakened until. And so in this case, what we need is a different function, which is called start. And start will happen the very first frame that the object is active. So awake will happen when the object is created, and usually start will be called immediately afterwards. So like awake is a first pass, everything gets woken up. And then anything that's going to be running will have its start function called. So this would be sort of the safer place to store that information. So we have the ball, and we can request its transform's local position. Local position is what we see when we look at the object in the transform, because it's relative to its parent. If I were to detach the ball, you can see these numbers have all changed because it's in essentially, since this is now at a top level, these coordinates represent world space. If I make it a child of the paddle, the numbers change so that the ball represents the relative position to the paddle. And you can see those numbers are much smaller as a result. So when we're resetting the ball, we care about that local position because we're going to parent it back to the paddle and then reset its position relative to the paddle. Because the paddle will move wherever it happens to be. It's following the mouse cursor. But we always want the ball to jump back to the paddle. If we save the world location, it's going to teleport back to wherever it was at the beginning of the game. And if the ball goes through and you're over on the other side of the screen, it's going to warp back there instead, and that's not correct. So we are now going to attach the ball, and we need to be able to do this kind of at will. So we're going to put this into a function that we call at the beginning of the game, but will also get called by the trigger object when the ball hits the trigger zone. So we're going to ask the ball to stick to us with this initial offset that we've got. And stick doesn't exist yet. We haven't written it. It's going to belong to Fireball. And we're simply going to take the transform of the ball and set its parent to be the parent that we've passed in. And once we've done that, we're going to reset the local position to that position. We should see is we're not calling the function. So we do need to make a change to our death zone. And initially we had set this up so that this thing loses a life on trigger, and we associated it with the lives manager script. So we could say, hey, we've got this lose life function that you need to call. But we need to do more than just call lose life at this point. We need to also tell the ball launcher to reset the ball. And so we're going to make a change here. Where our, one second, we're actually going to turn this into a generally more useful resource. And we're going to of a feature of Unity, which is its eventing system. So the first thing I'm going to do is I'm going to rename this. A lose life on trigger is very specialized, is very specific. What we want is a event on trigger. And we have to rename the class to match change the file name. And this is actually going to let us get rid of the collection to the lives manager. And this is what we're moving towards here is something called looser coupling. We're not explicitly binding these objects together. The event on trigger, or the lose life on manager specifically needs to know about a lives manager in order to be useful. What we really want to be able to say is we'd like certain things to happen when the trigger gets entered, without having to really specify exactly what things should happen. So if we change this to a Unity event, and this belongs to the Unity events namespace. We can instead say, instead of doing these very specific things that we have described in code and having to have relationships to all of those objects, we can now have this Unity event and say, hey, event, invoke yourself, which will cause it to send out messages to whichever other objects are associated with the event. So we go back to our death zone, we'll see that the visual here has changed. It's no longer looking for a lives manager, but has this list. And whenever we add a new item to the list, we can then associate it with another game object. So in this case, one of the things we want to do is talk to the lives manager. And we can say, go find the lives manager script and call lose life. So at this point, this will do exactly what it was doing before. As soon as the ball hits the zone, you see the lives counter goes down. But then we can also add a second event and say, hey, paddle, and you ask the ball launcher to reset the ball. And it teleports back, but it's also, as you can see, the stick didn't disable. So we should go back into Fireball, and when we stick the ball to something, we should also disable that rigid body's velocity. And so at this point, we'll actually turn that into a variable that we can hold on to. And here, this is some legacy code. Rigid bodies are usually the rigid body 3D, and I'm using the same name. So it's warning me that really what I should do here is say, this is a new rigid body, so it's going to hide the rigid body that belongs to the parent class of mono behavior. And we will need, this is where that awake function becomes helpful. So this code that we're doing on enable, we can now do on awake, and we can cache that rigid body so we can make use of it at any time. So we'll zero out the velocity. And we'll actually go one step further and we'll disable the simulation on the ball so that even though its velocity is 0, it's also not going to respond to collisions. It's going to be considered totally inert. And that means that when we fire it, we should also turn the simulation back on, or else it's not going to move. So the general sequence of events here is when we stick the ball, we are setting the parent and position to where the ball should launch from. We're zeroing out the velocity, we're turning off the simulation, and then when we fire the ball, we are setting the initial velocity, turning the simulation back on, and decoupling it from the game object that it was stuck to. All right, there we go. So it hits the zone, we've lost a life, and the ball's reattached, and we can't fire. So that would be because in our firing program in the ball launcher, in update, when we fire, we enable the ball so that it fires, and then we turn ourselves off so that you can't press fire again. So that means when we reset the ball, we also need to turn ourselves back on so that we can listen for that input. With fire, we can fire again. And there is right now no limit to the number of lives that we can have. So we're now into -3 lives. We really need a game over screen. So our lives manager had, I had set these up initially at the end of the last episode as system.actions, which are another way of doing events. This is a C# way of doing events, and these are perfectly fine. But it does mean that in order to get these events linked to things, we have to write something in code to say this thing should call that thing. And that either needs to be another script that's independent of the objects that are in play that is just simply responsible for linking everything together. But the Unity event system basically already allows us to do that visually, right? We can set up the links in the editor, and so it's just a lot cleaner to do it that way. So we're going to update these. You use the Unity event. And because these are no longer actually events, they're sort of Unity's variables classes, we'll go back to making them private again. But we do want to be able to control them from the editor, so we're going to make them serializable. But otherwise, the code will stay exactly the same. We've got here's what happens when a life is lost, and here's what happens when we lose all the lives and the game is over. So what we're going to want to do is set up a game over screen, and I'm just going to set this up as a 3D text object. That font is looking awful. Oh, because don't want to use the Unity text Text Mesh Pro is a much better choice for doing font rendering in the game. It's just telling me here that when I first create a Text Mesh Pro instance, I'm going to have to import the essentials. So it's going to add a bunch of Text Mesh Pro objects and assets to the project, but you can see that's already much cleaner. So we can open up the Text Mesh Pro object here. Game over. We will make it a little bit smaller. Let's make it centered in the window. We can set the X position to be perfectly centered. Find a nice size for that. And we will create a subtext mesh. We've got more text that we want to display in a smaller font. And we need to shrink this down so that it kind of fits cleanly. And I'm going to link these two objects together so that I can turn them both on and off together by controlling the game over screen's enable property. And that way our game over object, our game over event can, first thing we're going to tell it to do is turn on the game over screen. So we're calling the set active method. And the really cool thing about this as well is that for things like this, where there are some functions take parameters, we can actually hard code the bindings for those. So even though this game over event doesn't send any information, it's essentially treating it like a void function. It creates kind of a technical word would be a functor. It's essentially a way of binding the instructions for how to call this function so that it no longer needs any parameters because we're setting it explicitly. So we're saying we want set active to be true. So this is going to turn the object on. And then by the same measure, we want to turn off the paddle and the ball. So we can go there and we can say, we will issue set active commands to the ball and the paddle to turn them off. So 3 lives, 2 lives, 1 life, game over. What's missing is the whole, click the mouse and play again. We have, what we've seen is using this Unity event system, we can create really simple scripts that allow us to do complicated behavior in response to really simple inputs. And so rather than writing a script that reloads the scene when we click the mouse button, we can, again, decouple those two things. We can say we're going to have a script that emits an event when you click, and then we can have that call anything that we want to allow us to trigger some other kind of result. So just like we had destroy on our event on trigger, we can create a new script. event on click. And this is going to just watch for. Now we've actually got example code for how we handle watching for the button being clicked, and that's in the ball launcher. It's this get button down. So we can put that in there. And we can say when this gets clicked, and it might seem silly to write these really, really primitive one-line scripts, but you can see because of the way that eventing is set up, it gives us a lot of power um, to set up more complicated behaviors without needing to write one-off scripts for everything. So we can take this event on click, we can add it to our to our game over screen. And so this one won't run. It won't be watching for click events while the game over screen is disabled. But once it becomes active, then it will. And what we're also missing is the easiest way to reset the game back to its initial stage would be to actually just reload the scene that we're in, right? This current state that you see right now is what we see when the scene is loaded. So if we essentially reload the scene, then we can essentially reset the game by saying, we just want to reload back into the scene that we're currently in. To do that, we're going to need a script for loading the scene. And I have a question from Thrall3000 asking about the lives counter was a standard debugging thing. So just that, since I didn't want to set up a full GUI at this point to have, like maybe I want the lives counter to be a certain number of balls on the screen, or or just a text display. There's any number of ways that I could render that information to the player. But for debugging purposes, I just wanted to see something on the screen that I could use to keep track of the information in real time. And so there is a method that Unity objects have called onGUI, which this only works in editor. It does not work in game, and allows me to use the GUI layout system to render whatever things I want to see. So in this case, I'm just using it to just quickly say, here's what the current lives are. And if I were to build the game, you wouldn't see this. So it becomes essentially debugging information in this case. And _func is asking whether or not Unity has a finite state machine out of the box. It does not. State machines can be a common tool. I have worked with state machines on a number of projects over the years, and there is a Unity asset called FSM, or finite state machine. I recommend it. I've used it. Yeah, Playmakers FSM. If the price tag is not prohibitive, then it's a very robust state machine system. It allows you to visually your state graphs as well as set up ways of it having those state graphs interact with the Unity, like with the scene hierarchy. So you can engineer all kinds of complicated behaviors. Um, it's pretty good for that. That said, you don't strictly need that because you can also use Unity like a state machine. If you consider your scenes to be states, then you can build your game rather than having like, okay, I need to have a title screen, and then when you do that, the title screen needs to go away, and then the main game needs to come in, and so on and so forth. You can just build those up into separate scenes and say, okay, the title screen is where we launch into, and when you click play game, then it's going to switch from the title screen scene to to level 1 scene, and each level of your game can be a separate scene. You can just chain things together that way, and that might be a simpler way to set up a kind of state machine by just controlling your transitions from level to level. Okay, so we had created the scene loader. So using the scene management namespace gets us access to the scene manager. And I forgot to, sorry, on the break, I will shut down my notifications on Discord. Keep forgetting to do that. All right, so again, really simple scene or script. We are providing it with a scene that we want to load, and we just tell it when we trigger this load scene method to call the scene manager. Unfortunately, because scene manager itself is a static class, this method, it's not a mono behavior. I can't attach this to a script. Otherwise, I could just put a scene manager on an object and then use the event system to call it directly. I have to put together this little proxy. But at least, again, it's a very simple script. And simple scripts are often the best scripts. So now that we've got that, we can put our scene loader on the same object. We can say, we actually want to load sample scene again. That's the scene that we're currently in. Maybe actually now would be a good time to rename it. So I'm actually going to go into scenes and take the level that we're in and rename it to main game. Yes, so it renamed it. Now we need to reload. And at this point, we can now drag ourself into the event handler. And we can talk to the scene loader and say, call load scene. So 2 lives, 1 life, game over, click, and everything restarts. So we're back to 3 lives. We're back to a rebuilt game mode. And we're ready to play again. So at this point, we've got our basic game loop. there's a few more things I want to add in here to polish this out before we move into the power-ups, because we would really like to have that lives display be part of the game field, and we should probably have scoring. Otherwise, it's not really much of a game. And so there was a question is gone now. Was maybe answered by somebody in the, okay. Hall 3000 was asking about what programming language this is. So yeah, this is C#, which is, I think, the only scripting language that Unity supports now. It initially supported JavaScript and a kind of a Python Lua type language called Boo. But I think at this point, the engine's just dropped support for anything aside from C#. But it's a great language and very similar to Java, if you have any experience with that. I find it easy to work with. It's got a lot of really powerful features and overall awesome language to work with. All right, so lives. Let's move that debugging text into actual text. And we're going to do that again with not that one, but the Text Mesh Pro. So lives, let's shrink this down again. We can make this a lot smaller as well. So I'm just going to set it up in the bottom corner here. And actually something else that's been bugging me, that death zone is the second the ball hits the zone, it triggers. So it's when the edge of the ball touches. I'd like the ball to travel a little bit further before it resets so it doesn't feel so abrupt. So I'm just going to move that down a little bit while I'm here. So we need to display the current number of lives. We're going to need to add a lives displayer script to this. And what the lives displayer, what we want it to do is show the current number of lives. And we don't need it to do it all the time. We only need to do it when the number of lives change. So the way that I want to do this is, rather than making the lives manager, which is what currently has the number of lives, a property of the lives displayer that we have to link, because we kind of want the relationship to be one way. If the lives manager has to tell the lives displayer to update, then it creates a dependency that goes in both directions. But we can use that Unity event system again to make the dependency flow in only one direction. The lives displayer obviously needs to know about the lives manager because it's the thing that keeps track of the lives. But the lives manager doesn't actually have to know anything about the existence of a lives displayer because it's not its job. So what we'll be able to do in this case is set up our Text Mesh Pro object as a property. So again, we bring in the the TM Pro namespace for Text Mesh Pro. And then our text mesh has a text field which we can set to whatever we want. So we'll set it to lives, and then we're going to append. So this is a string concatenation. We're taking multiple pieces of character data and smushing them together to make one longer string. And so we're going to say, set the lives counter to show us how many lives we've got as a text value from the text manager. But the text manager itself doesn't have a lives display. So we got to go back there. We've got the number of current lives, and it's set up as a private integer. This is because we don't want anything other than the lives manager to be able to change the number of lives that you currently have. We can just say you can lose a life, but you can't right now gain lives. And if we do add gain lives, we would like it to be something where we ask the lives manager to gain a life as opposed to saying, hey, the lives are now whatever. But we do need to be able to get that information. So just because the variable is private doesn't mean we don't want it to be something that we can read. So we're going to use something called a property. And a property is a way of writing functions that don't look like functions. You don't have to put this, you don't have to have the parentheses around them. You can interact with them like they're variables. And this is done by two methods that you can implement. One is called get, which is supposed to return whatever value you want the property to control. And the other one is the setter, which allows you to set the value. And one or the other or both can be defined. They don't have to be. So if you make something that is a getter only, it essentially looks like a variable when you're working with it in code, but it is in fact function, and it becomes a read-only function. So if I say get return current lives, that means whatever value is in here, we can look at it, but we can't change it. Only the lives manager itself has the ability to do that. But the other thing that we need to do is be able to alert the lives displayer that the lives have changed. So we do need to add an event. We'll get this working and then we'll take a short break. People can ask questions and we'll resume probably after about 5 or 10 minutes. Oh, we already have events in here because we had the life lost and the game over. We could tie this to life lost, but the problem is that this Unity event isn't capable of sending any information. We want to be able to pass the lives manager into the function call dynamically, right? We had the other situations where we could set static values, but this is now a thing where we're like, there's a piece of information we want to pass in. Unity events come in a few different flavors. There's Unity event just like this, but then there's also parameterized Unity events where you can specify to 4 additional pieces of information to send when you invoke the event. But a quirk of the way that this is set up, we can't do this. We can't say this is a Unity event of type lives manager. It will get cranky about this. So what we have to do instead is create a wrapper class for this. And this is a good example of what we would call boilerplate, because it's just something kind of rote that we have to do, and there's no actual code that we're going to put in this. Just by declaring this object, it's everything that we need to do, and we're just saying we're binding a lives manager to as the single parameter for this lives event. So now we can, oh, that's still supposed to be a Unity event, but we need to create a new type of event. It is a lives event. And this is what we call when we change a life. So anytime that we adjust the number of lives, we need to call this event. But what would be better is if we only had to worry about that in one place. So here's where this property comes back into play. If we write a setter, we can use this to update the current lives to whatever value we set. So if we ask it, if we just say, print lives, then that's calling the getter automatically and getting us the current lives. If we say lives equals 5, like it's an equation, that assignment will call the setter, and whatever value we passed in will show up in this special value keyword called value. So at this point, and we can even compare what the values were before, right? So if we are changing the number of lives, then we should fire off this event. So if current lives is not equal to value, then that means we're about to change it. So then we're going to update current lives, and if it's changed, then we can say lives changed, invoke, and now, because we said it was a Unity event of type lives manager, the invoke method now expects us to give it a lives manager so that it can pass it to anyone who's being called. Now, we are the lives manager, so we just say this. We could have made this an event that takes an integer, and we can say, here's what the lives have changed to. But by passing in the actual object itself, if we if we add more information later, then we don't have to change the types of parameters that we call, right? The lives manager, the displayer, or other things that care about the lives changing may want to ask for additional information from the lives manager. We don't know. We don't want to make that assumption. By doing it in this fashion, it gives us a little bit more flexibility, which is, again, one of those principles of solid programming, that open for extension, closed for changes. We don't want to have to go back and add more events every time we need to do something new with the concept of lives changing. So we're invoking it. This should all be correct. Oh, except that at this point, we're going to say, instead of talking about current lives directly, we're always going to reference lives, because that's going to call the setter, which will then change the value current lives. And if it's changed, it'll invoke the event. And then that way, all of that repetition is avoided. We can just say, we can talk about lives like it's a variable with this extra behavior that gets tacked on. But I had also just said that we don't want current lives to be something that other objects can mess with. And this is already a public getter, which means that this is currently a public setter. And this gives other parts of the program access to changing the lives in a way that we don't want it to. Fortunately, in C#, you can change the access levels of the getters and setters independently. to restrict the access further. So even though it's a public getter, it is a private setter, which means that it can only be changed by the Lives Manager itself. So if we go back to the Lives Manager, we've now got this, oh, something I think is wrong here. Oh, sorry. This is not displaying one more other piece of boilerplate. We have to tell Unity that this object is serializable so that it is visible within the GUI. So when it finishes recompiling, we now have lives changed added. And you can see here that it's got a slightly different bit of information here that says that this is a Lives Manager based event. So if we link our lives display in, we actually get so we have not added our, right. We have not added our lives displayer to the script, and we have to link it to the text mesh. So we'll drag that into there. And now because we have something that will take a Lives Manager as a parameter, we go back to the Lives Manager, the Lives Displayer, you can see we've still got access to all the other public static ones where, you know, if we call this, we're going to say we can type in the information that we want to bind, and that will never change. It's always going to be called exactly the same way. But we also get access to dynamic ones. So now we can say live changed, and we don't have to give it any information about the parameter because the parameter is automatically provided as the this parameter when we called invoke. And this happens every time the lives change. So we run the game and we can see it's showing 3 lives because when we did the initial assignment, the lives changed from 0 to 3. So that causes the lives display to update. And when we lose a life, it automatically updates. So at that point, we can go back into our Lives Manager and we can get rid of that debugging code because we don't need this anymore. It's gone from debugging information to actual information that we want the player to see. So we're going to take a quick break, 5 minutes or so, and everyone can grab a drink of water, stretch the legs, use the bathroom, and we'll come back. We'll add the scoring system. It's going to function in a very similar fashion. And then with whatever time we've got remaining, we'll start working on power-ups. Okay, see everyone in 5 minutes or so, and feel free to ask any questions. We'll do a quick Q&A after the break. All right, thank you. And welcome back. Don't see any new questions that have come in. So we will
No.
just continue on, and if you have any, feel free to put them into the chat, and the moderators will get them to my attention. All right, so score. Score is going to be pretty much the same thing, so this is going to go pretty quickly. Going to create a score display object. We'll move it over a little bit. Now, instead of a lives displayer, we're going to need a score displayer because the object is different. So we'll remove that component. But the objects are so similar that we will take the lives displayer and we'll just duplicate it to start. And just go about changing And now the next thing we'll have to do is fill in all these bits and pieces that are missing. So we're going to need a score manager, create a new script. And like with the lives manager, going to have this scoring system and the current score. And the score changed. So we'll grab all of that. Sometimes things end up being similar enough that you don't really want to make a generic solution, but you do find yourself just kind of changing all of these things over one at a time because it's essentially a clone. That's fine the first couple of times that you do it. If you start to see yourself doing that over and over and over again, where there isn't a real good reason for it, then that can start to become an opportunity to go, what's the pattern underlying this? And can we actually build something that allows us to just sort of take all of that common functionality, put it into a base class, and then have it differentiate. In this case, it's still a good example because even though score and lives are both integers, and you might be tempted to think, well, the pattern is that we're sending an event when an integer changes. That's a really generic thing, a little bit too generic. And in this case, even though the code is kind of exactly the same, the concept of the score and the concept of the lives are fundamentally different kind of code objects, right? They might be integers under the scene or under the hood, but a score manager and a lives manager are managing different concepts. So it makes sense for them to be different things, and we don't necessarily need them to share any functionality. So We're going to need a score event. All right. And actually, this is the thing where, getting ahead of myself, but we will actually want to be able to change the score um, because other objects are going to want to say, hey, we need to, add or reduce the score based on power-ups or penalties or whatever kind of thing. It's a little bit more. It's all right if other things are messing with it because, again, because we're not actually touching the data directly, we are going through some code. The data itself remains private, even though anything's allowed to change it. We'll know when it changes and the events will still propagate. So our score display needs a score displayer, which we can link to the TextMesh Pro. Now, we've got our lives manager and we've got this lives manager object. It is a little silly and redundant to make another empty game object for the score manager. I am just going to rename this to the game managers object, and then this is where we can put all of our top level kind of manager scripts that need to deal with stuff. And then the way the score manager and the lives manager are both in the same object. We could have put them on the camera, we could have done any number of other things, but it does make sense for them to sort of be together. It's probably worthwhile for them to be on their own empty game objects just so that they are functionally independent of everything else in the game. And we can attach our score display. And you can see we also get access to the dynamic event for score manager. And our score manager, when the game resets, should also set the initial score. Something didn't happen. Oh, right, because the initial score, in this case, because the initial score was 0, when we set it, the default didn't cause it to trigger. So I'm actually going to set this to a really ridiculously small, like the smallest negative number that we can have on an integer. Could also actually use max value. If this was an unsigned integer, that would maybe make sense because the minimum value would be 0 on an unsigned integer. But the bottom line is we just want it to be something that's not 0 so that we can set it to 0 and have everything propagate correctly. All right, so now we can see the scores reset to 0. The display is getting updated. But of course, the score doesn't actually change when we hit any of these bricks because they don't know anything about the score manager. They have no way of communicating that information. So we need to have something that's capable of letting the score manager know that the score needs to change. And that means that we should create a script that can do that. We'll call that a score adjuster. And score adjuster will allow us to set a value, and then that value will be sent to the score manager whenever we tell it to modify the score. Now, the score manager here, it thinks we're talking about the class, and score is not a global property. We could make this a static property of the score manager. We could also use a singleton pattern here, but it's that can sometimes get you into trouble. What if we need multiple score managers? What if there's a player 1 score manager and a player 2 score manager, right? The score managers themselves, if you can have multiples of them, then you don't have to write one score manager to keep track of the scores of all the players. You can have one score manager for each player and make sure that the correct things are connected to the proper score managers. And then that makes everything kind of a little bit more modular and easier to deal with. But it does create a problem where we have to link the score manager to the score adjuster. And so I'm taking advantage of some what's referred to as syntactic sugar in C#. I'm declaring a property like we did before, but I haven't given any instructions for the getter and setter. When you do this, behind the scenes, C# is essentially creating a hidden variable to store the score manager object, and it's implied that the getter will get that value and the setter will set that value. This is essentially a way of saying we're going to treat this like a variable, even though it's a function or a property. This is so that if we need to actually do something more complicated later on, we can declare the backing variable explicitly and update the code. But for now, because all we're doing is just getting and setting information, we can use this shorthand. Saves us a bunch of typing. And the reason that I'm doing it this way, we could declare the variable as a serialized field and try and link it in, except for one problem. And that is that we are going to be adding the score modifier to our brick object. And the reason this is a problem, why is it not showing me the, oh, whoops. Typed too fast and it created a new script called score add. That's why that didn't work. All right, so if we open up the brick, we attach the score adjuster to the script, and we'll make each brick worth 100 points to begin with. The thing is that because these are prefabs, and they're dynamically spawned at the beginning of the game, we can't link the score manager that exists here to the brick object in advance. Because what we really need to do is attach the score manager to the brick whenever whenever a new brick is created. So who's responsible for creating objects? Well, right now that's the field manager, right? The field generator is the thing that allows us to control the shape and size of the playing field. It takes the brick prefab and generates all of the bricks and lays them out at the beginning of the game. So this is where we're going to need to again set up another Unity event. And seeing these familiar patterns showing up time and time again. So then here, after we've instantiated the brick, basically when the whole thing is set up down here, we can go, if there's anyone listening to the onCreated event, we can pass it the brick that was created. In the other cases, we were using this because we were passing in the object itself, right? The score manager was sending a score changed event and passing itself because we needed a score manager, and it was the score manager in question. In this case, we don't care about the field generator, we care about the actual brick that got created. So the field generator will have this onCreated event, and anything that cares about a brick coming into an existence can register to find out what brick got created. And so that means that our score manager which cares about making sure that the bricks know about itself, needs to have a brick spawned event and at this point, what we want to do is we want to take the game object that was created. We want to see if it has a score adjuster. And if it does, then we want to we want that score adjuster to know about us, the score manager. So we can ask the brick, do you have a score adjuster? And if we do not, then this variable will be set to null. So if it's set to null, we're done. This brick that got spawned doesn't actually adjust the score when it gets destroyed, so it doesn't matter. We don't care. But if it does, then we want to tell it about the score manager it should care about, and that's us. So we are almost all the way through. If we run this now, we're going to see that the score's not changing. But if we were to look at one of these bricks, we go into debug mode. Oh, we are also seeing that our score manager has not been set, and that would be because our score manager was not registered with our field generator. So let's go back, get everything talking to each other. So on created, we can give it the game managers. We can say we're looking for the score manager. We're going to give it the brick spawned event. Now we run it. Score still not changing, which I expected. But now, under debug mode, we can see that the game manager score manager has been linked correctly to the bricks that were spawned in after the game started. So the only thing that's missing is that our score adjuster is not being told to adjust the score when the brick gets destroyed. So again, events to the rescue. Right now we've got this destroy on collision script, and it's got this, right, it's listening for collisions and then triggering destruction. Well, as we saw before, we adjusted the pattern of our trigger system so that we had a event on trigger. And we can do the same thing with creating an event on collision, or we could even go into event on trigger and add a collision thing. That might make sense because they are kind of related, and you might, rather than having to attach two different scripts, you can just say, okay, we attach one script for handling all kinds of collision events, and you could just link up whichever events you care about listening for. So on collision enter, we need to create losing my ability to spell. So now we've got two separate sets of events, one for triggering and one for collisions. I guess potentially the use case for splitting them would be that usually a collider can only either be a trigger or not. You're not usually going to get both from the same object, but it becomes kind of a back and forth. We can, in this case, though, when we were looking at the things that we can evoke on game object, let's just grab something with an event here, right? If we look at the game object, there's no destroy method. We can't make a game object self-destruct using these static functions, which is, to me, feels like an oversight, kind of a pain. It means that we do need to change this destroy on collision to just call it a destroyer. And this is the silliest bit of boilerplate that we're going to write. Call it a destructor, and it will self-destruct. That's still going to belong to the brick. We need to rename this to be destructor so that Unity knows what it's talking about. So the script is still attached. It's still going to do the thing that it does, but now we can add our event on trigger to the brick as well. And in this case, we care about the collision. And we're going to ask the destructor to call its destruct method. And then we're also going to ask the score adjuster to adjust value. So it blows up, but it also sends off a message to the score manager before that happens. And there we go. We've got score. So every brick is worth 100 points. We could do things like the score manager could assign different values to the bricks, even randomly if we wanted to. There's sort of unlimited options for how we do that. They don't have to be explicitly hard-coded in. But for now, it's fine. And at this point, that's the fundamental of the game, right? We're about half the way there, or 3/4 of the way there. We need to have support for more levels. We need to have support for the core power-ups of the game, which are things like lasers and multi-ball and changing the size of the paddle, growing it, shrinking it. And then, yeah, being able to detect when we've eliminated all the bricks on the screen and move on to the next level. So we've got about half an hour left. I think we'll jump into starting with the power-ups. And let's start with the one that is probably the most fun. A lot of today has been the same thing repeated over and over and over. So let's go with lasers. To our paddle, we're going to want to let's go with laser emitter. You'll notice that one of the things that happens with this design approach, the solid programming that I have been talking about, which if you were not here for the first episode, solid is an acronym. It's a 5-letter acronym made up of 3-letter acronyms that have to do with sort of fundamentals for how to write object-oriented code in a way that is easily reusable. So the S in solid means single object responsibility. The idea is a script should only do kind of one thing. And you can see that in most of the scripts that we've written, they're very focused in their purpose. The only exception to that so far was the decision to take event on trigger and collision and put them into the same thing because they're both kind of related to physics events. But otherwise, everything's been really kind of small and modular. The second part is the open-closed principle. Things should be open for extension, but closed for modification. This essentially means that you only want to add new code as much as possible, because anytime you change existing code, you run the risk of things that were already built having their behaviors change on you. And if a bug happens because of that, that's what's referred to as a regression bug. And regression testing is probably one of the most time-consuming elements of quality assurance in game development. So anything you can do to minimize regressions in your application, the better off you will be. And the easiest way to do that is to build your project so that as much as possible, you are only writing new things. Once you have built something, it should be something that ideally you never have to touch again, unless the way that thing actually works fundamentally changes. But even then, you might be able to get away by subclassing that object and creating new behavior, which is that open for extension principle. If something needs to do something more than it was, it becomes like a yes and concept. You can say, well, all right, let's take the base object, we'll extend it, we'll add the new functionality. That way, everything that cared about the old version of the object still works, and then everything that only cares about the new version of the object only needs to know about it, right? I won't bother getting into the rest of the acronym things, but if you want to look it up on Wikipedia, there's lots that's been written about solid program design, and it's worth reading up on. Okay, so what I was trying to say though was that in this case, sort of an artifact that I find of object-oriented programming is that when you're programming in a solid philosophy, your scripts tend to be more verb focused. They're not what the thing is, but what it does or what it's responsible for. Because the paddle is made up of a couple of different behaviors, right? It has to track the mouse, it has to launch the ball. I could have written a paddle script and I could have put the mouse tracking and the ball launching code into the paddle and said, this is what a paddle is. It does these two things. But by breaking it apart like this and going, well, the paddle is really made up of two behaviors, and each behavior gets to be its own script independent. That means if I need something else that has to track the mouse later on, I can reuse that script. If I need something else that has to launch a ball, I can reuse that script. When things only do one thing, it's easier to stick them together. It's much harder to pull them apart later on. So we are going to add our laser emitter to the paddle. Let's do it this way. And this is going to be a thing that is basically responsible for firing our lasers. So in order to do that, we're going to need a couple of pieces of information. The one thing obviously we're going to need is if we're spawning some kind of projectile that we're shooting, we need to know what it is that we are going to spawn because it's dynamic. And then the other thing that we would want to know is where are we going to spawn them? And so this is sort of like where the mount points that the prefabs are going to be created on. And then the purpose of the laser emitter is to shoot. And so it's going to take the prefab and it's going to spawn one on each of the spawn points. And it should probably also be responsible for telling the prefabs which direction they're going to be moving. So then we should also have we've actually already got a script that does that, so that becomes yeah, we can just put that on the prefab then. We don't need to worry about providing that information here, at least for the time being, because when we spawn these laser bolts, they're just gonna fly in a preset direction. We're not meant to have any control over which direction they travel. So this works out. All right, so this is a for each loop. It is one way of iterating over a collection of objects and saying for each var t in spawn points means that this list of spawn points, which allows us to have a whole bunch of transform objects in an array or a list, like lockers, that you have a whole bunch of compartments in sequential order, and those can store a piece of information. We want to go through each of those spawn points in order and do the same series of operations. And so then as it goes through the list, T will take on one of the values in turn and allow us to do something with that information before moving on to the next thing. So we need to create an instance of the prefab. And then we need to put it where the current spawn point is. And the objects themselves are going to have the that fireball script essentially, because that allows us to give them an initial velocity and heading. So this should be all that we need to do for that. But now we need to create a something for it to spawn. So we'll build that in here, and then a good choice in this case would be a capsule shaped sprite. So we need to create a new sprite. I guess more circular. And yeah, I'm going to cheat here. We'll do this as a 3D object. Be a little bit simpler in this case. As a capsule. So we can scale this down. I get a general sense of the size. So I want it to be a little bit thinner and a little bit smaller. Why is the capsule collider not? Shrink the radius, give this a sort of a roughly matching bolt size. And we do want it to be not gray. So I'm gonna create a material for this. We're going to make it emissive, which allows us to adjust the color that it appears to be glowing. We don't actually want it to care about lighting. So I'm actually also going to make it albedo, which is essentially the color that it would be if it had white light shining on it. I'm going to make it black. And we'll get rid of any metallic properties, we will give it an emissive color. We can now make it a nice kind of solid red. If you actually have an artist, they'll be able to do a better job of this than I do. And then we can assign that material to our laser object. So now it's a nice little glowy red. And we need to give it a, so it's heading up, so that should be an initial heading of 90 degrees, and let's try a speed of 10. Nice thing about this is we can, since this is not yet a prefab, we can just run the game and watch what happens. So it's not, oh, it needs a rigid body in order for it to be able to travel. Not a 2D one in this case because it's a regular. That was the wrong direction. Heading of 0 is right. Graphically, this is going to be a 3D object, but physically it needs to be a 2D object. So we're going to get rid of the 3D capsule collider. We'll go back to a 2D rigid body. We'll re-add the collider once we've got this working. So that's a good speed. It's wrong direction. Now it travels up. That's good. Now we can put a capsule collider on it. It'll need to be a capsule collider 2D in this case. It's already been correctly set, so it's got the right size. Should even, like a ball. Cool. All right, so it bounces like a ball, but it also reacts to the collision sort of in the wrong fashion. And we don't actually want it to bounce, we want it to travel. So we can change this into a trigger, which means it flies off. So that means that we need to give it an event on trigger, script, and a destructor. So when the trigger enters, we can pull ourselves up. But we also need to make it destroy the brick that it's hit. In this case, it should just fly off and it hits the brick and dies, but it's not telling the brick that it needs to blow up. So to solve this problem, we're actually going to need to change these events so that we can pass in the game object in question. We do need this to be a dynamic event at this point. So this becomes a change where we're still kind of, we can treat this as adding new code, because if we move from being a Unity event to a Unity event that takes a game object, and the scripts that didn't care about the dynamic information will just continue to function as they did before. And we've already got a game object event because we wrote that for the spawner, right? In the field generator, we created this Unity event for game objects. So we can make use of that. you can change these into game object events. And we can pass in the game object in question. That we collided with. And this should not break anything because the previous scripts that didn't care about the game objects should still function. So if we run this, everything should work as it did before. So this is an example of a change that was not designed to cause a regression. It thankfully did, is a little bit on the sketchy side. I was going off the fact that I was confident that those changing the type of the event was not going to break the linkages with the previous things. If that was actually going to happen, then it would make sense for me to create a new kind of event on trigger script that was designed to take, one version of event on trigger that worked with Unity events and another version of event on trigger that took the enhanced version, because then that way it doesn't break the things that were already written, and I can either go back and retroactively change them, or I can just leave them and live with the fact that I've now got two slightly different versions of the script. But that does mean now that we can now we won't know, we can't link this to the object that we're getting passed in, the thing that we want to destroy, which means that we can update the destructor script, give it a new piece of functionality, and again, this is adding new code. It's not changing the existing code. So things that, we're extending this without having to create a new class, but it still falls under that open for extension, closed for modification. And it means we can now add another reference. We're going to call destruct on ourself, and then we're also going to call destructor destruct other. And so on collision, the laser should hit the brick and trigger it to blow up. Now, interestingly, though, it did not, that collision didn't cause us to gain score. So that's a bug that I'm going to look at, although I will do that between sessions, and we'll talk about the solution to that at the beginning of the next episode. But we can turn this into a prefab. Go to our paddle. We can add the bolt to our emitter, and we can define two spawn points. One that is going to be, so let's see, how wide is this object? It's 1 unit wide. So, oh, we don't have to think about that because it's a transform. So we're going to add two empty game objects. And now we can take these objects and we can actually position exactly where we want the emitter to spawn from. That's the left one, so it should be on the left side. Could have just called them 1 and 2, and then I wouldn't have had to worry. But at this point, we can then drag them in. And our paddle, the ball launcher is currently listening to the mouse click itself, but we still have our event on click script. So we can tell the laser emitter to shoot. So we have lasers that are not earning us any score, but let's see, it was pretty straightforward to add a weapon power up into the game, or at least the ability. And we can also blow up the ball, so there's a bug there. That one's simpler to deal with. We can put these prefabs on different layers and make it so that lasers will only interact with the bricks. But we will get into that, I think, next time. So thank you everyone for joining me on this episode of Recoding the Classics. Hope you've enjoyed it. We've got a few minutes to do any last quick questions if anyone wants to fire anything off, but otherwise I will update the repository shortly after we're done here, and stay tuned for when the next episode is announced. Thanks. So, do we have... one question that was asked earlier that I didn't get around to, Danica Rose asked, can you click and grab the ball? Not while the game is running. I can grab the ball object and manipulate it in terms of its initial position, but it had been placed here as a child object at the paddle so that I could define where sort of the ball's reset position should be when we reset after losing a life. I hope that was the question you were asking. If it wasn't, then feel free to clarify. Yes. So adding a sticky paddle as a mechanic is absolutely something that we will do. So yeah, by default, the ball would not stick to the paddle, it would bounce, but we would be able to add a feature later on to say, if you've collected that power up, then when the ball hits the paddle, it'll stick so that you can then reposition the ball and relaunch it, and it'll fire with whatever velocity it would have had reflected. So it's slightly different from the initial ball stick kind of functionality in that we're not going to zero out the velocity, but yeah, it would work in a similar fashion. We could add friction to the paddle. The problem, I guess, would be we don't want to have the ball slow down too much right now. We might want to. That's one of those things where we could try it. We'd have to see what the impact on the gameplay was. Actually, one thing that I had noticed that felt like would be an interesting feature to add was that we're kind of cheating on, like, right now the physics simulation is really accurate, but that can result in situations, if I can get it to line up correctly, where I might get a really kind of glancing blow where the ball is gonna, yeah, like that, right? And it might get a really kind of zigzaggy angle, which, while accurate, might not be a lot of fun. And maybe we add a something to the collision events so that if the ball has too much left-right velocity relative to its up-down velocity, that we kind of tweak it when it bounces off a surface so that as it hits the wall, it subtly kind of moves faster. But that might also just be really weird to the player, so we'd have to really check that. Maybe that only happens when it hits the brick and not bricks and not the side walls. But maybe it's fine. It's one of those things that you'd want to play test. So I think then we'll wrap it up for tonight here. And again, thank you everyone for coming out. I had a lot of fun with this. I hope you did as well. And we'll see you on the next episode. Good night.